Good evening, children. Today we are going to start a new chapter, which is aldehyde, ketones, and carboxylic acid. So here's the first question on your screen, and everyone can try. Okay. So here the answer has been highlighted for your reference. Okay. So let us see what's given here in this question. It is given here that we have CH3, CO, CH3 in the presence of dilute BaOH whole twice. Right? Okay. Now this is our star carbon because it has the functional group. Right, children? Okay. Now what happens here? This one is your alpha carbon. What carbon? Alpha carbon. Alpha carbon is having a hydrogen, right? So I can write it like this. Now this OH minus from this BaOH whole twice is going to take away the alpha hydrogen and you are going to get an anion, right? Yes or no, children? Yes. Now there is going to be a condensation which we know as aldol condensation. So this reaction, we know that this is dilute BaOH whole twice, or it would have been given dilute NaOH. Yes, and we see that we are having an aldehyde or ketone with an alpha hydrogen. So that's why it is undergoing aldol condensation. So let's see what's going to be the product. So it's going to come and get attached here. Yes. Then this bond is going to go up and you're going to add a hydrogen here. Yes. So what's going to be your product? Okay. As only one reagent is given to us here, if it was given heat, then we would have undergone removal of water, right? But as nothing is given to us here, then I can see that what are the groups that the final product has? This is our final product, and this is your ketone, and this is your alcohol. As you can see, your answer is highlighted here, where it is alcohol and ketone, right? Okay. I hope this is clear, children. Let us move on to the next question. So here the next question on your screen. You have to identify that what kind of reagent you are going to use here, right? Okay. Now children, I've already highlighted the answer here. You can see what happens here is we are having RCOOH, right? And X is given to us here, H2O, HCl. Now we know that when we want to directly convert acid into alcohol, when you want to convert acid into alcohol, what do you need, children? We need a reducing agent. But acid gets converted into aldehyde, then into alcohol, but as we're directly converting, so we need a very strong reducing agent. So the strong reducing agent converts acids into alcohol. So you can think of LiAlH4, right? Okay, we'll think of this. Now, You can see this, that we are having one alkene and we are getting a primary alcohol as your major product. And in what reaction you get alkene and you take alkene and you get 1 degree alcohol as a major product? That reaction, children, is hydroboration oxidation. Is what? Hydroboration oxidation. And we know that in this reagent, the main reagent that we use is diborane. Yes, diborane, which is also a strong reducing agent. Yeah, that's why we cannot use this one here. So this is going to be your correct answer. So diborane is going to be your answer. Yes. So next question on your screen. Yes, we know what kind of reaction this is. This is a direct question and an easy one. We are having a RCOCl. This is your acid chloride. Which one? This entire thing. And your R can be an alkyl or an aryl group. Yes. Now, when this is reduced, yeah, it is undergoing reduction in the presence of hydrogen. This palladium here, it acts as a catalyst, right, which will enhance or catalyze the reaction, right? This BaSO4 is going to act as a poison here, going to act as poison. Okay, why does it act as a poison? Because we know that if this is getting converted here, this is reduction process has taken place, right? This might further get reduced into alcohol. So to slow down this conversion, we use a poison. Yes. In order to slow down this reaction, slow down the reaction and stop the further reduction. Okay. So this, what does it do? It stops further reduction of aldehyde into alcohol. Who? Your poison, that is your BaSO4. And this reaction, children, is commonly known by the name Rosenmund reaction. Yes, children? Yes. Okay. Okay. Next question on your screen. Let us read what's given here. Reagents which can be used to convert alcohols into carboxylic acid. So we have, suppose, yes, we want to do any such kind of conversion. So what are we doing? We are directly converting your alcohols into acids, right? So when we convert directly, we need a very strong oxidizing agent. So when you need a very strong oxidizing agent, this is a Jones reagent. This is again very strong one. This both will not convert, right? They are oxidizing agents, but this converts into aldehyde or ketone. Yes, 1 degree alcohol in presence of copper 573 Kelvin gets converted into aldehyde. 2 degree alcohol in presence of copper 573 gets converted into ketone. But if you are taking 3 degree alcohol, beware, you are going to get alkene as the major product, right? So this is again important. Again, this is not that strong enough to convert into RCOOH. Okay, so these three are going to be your answer. So next question on your screen. Try everyone. Pause the screen and try. Okay, I hope you all would have figured out how to solve this question. So let's see, children. Here we have ketone, right? HCN, when you add, you're going to undergo nucleophilic addition reaction. What reaction? Yeah, so when it undergoes nucleophilic addition reaction, it forms your cyanohydrine. I hope you all know how. In case you don't know, I'll show you how this reaction is being done. So how does this work, children? This goes here. Yes? So when it goes here, bring it down. This is OH and CN. How? This is minus, H is positive, Cn is negative. So Cn will go and attach here and H will go and come there. Right? Now children, we look at this carbon. This is going to be your main carbon. Right? Now here, we are having two carbons here. Yeah? You know that whenever there is concentrated H2SO4, it is undergoing to go dehydration. When it undergoes dehydration, it's going to form alkene. Who? Your alcohol. Yes? And this H plus is going to convert your cyanide into COOH, right? So this is going to go, so there are two hydrogens here. Both these positions are equivalent. You can remove hydrogen from any of the place, right? So you have removed one hydrogen, this OH will go from here, this hydrogen comes here, right? So you are going to get your alkene, and these parts convert, they get hydrolyzed. Yes, so if we see the final product here, children, these are two hydrogen here. Yeah, this goes there, this bond comes here, you remove water from here, so what are you going to get? Yes, and this one, children, is going to be COOH. Yes, so this is going to be your final product. I hope this is clear to everyone. We got C. Yes, so I'll write it down here. This bond goes here. I have removed from this carbon. This comes here, this goes there, so you remove water. Yeah, so your water is removed and this gets hydrolyzed, COOH. So this is your final product. Yes, children? Okay. I hope this is clear to everyone. Let us move on to the next question. Next question on your screen and try. So when you are able to identify, children, what is going to be the answer here? So this reagent, if you see, it is silver nitrate. Okay, sorry, ammonia. Okay. What is this reagent, children? This is Tollens reagent. This is Tollens reagent. Were you all able to identify that this is Tollens reagent? Yes, ammonical silver nitrate solution, right? Okay. Now, this reagent, does this work on ketone? No, it does not work for ketone. Does it work for aldehydes? Yes, it works for aldehydes, right? What does it do? What kind of reagent it is? It's a very mild oxidizing agent. Yes, this is also called as silver mirror test. What does it do? The Ag plus gets converted into Ag and the CHO group, it gets converted into COO minus. These are the things that takes place, and this is white in color, or it looks like silver mirror. So you can see that there's a carbon here, there's a carbon here, this carbon has CH3 here, this carbon has hydrogen here. So can I say, children, this is aldehyde? Can I say that this is ketone? Yes. So when Tollens reagent comes, which part is going to respond, children? Obviously this part, the aldehyde part, is going to respond. Yes. When this part responds, so what is going to be a product? This is going to be as it is. Only this part we saw that CHO is going to convert into COO minus, right? So this is going to be your major product. Yes. Okay. So this is going to be a product, and why did this happen? We understood that from this reagent. This is Tollens reagent, and this is our target area, right? Okay. So is it clear to everyone? Should we move to the next question? So again, next question on your screen. I'll become invisible so that you can see the question. Try for a minute. Okay, so I hope you all would have solved it. Let us see what's given here. So we're given with aldehyde, right? This is acetaldehyde. You otherwise call it by the name ethanol. right? So this is basically your aldehyde. Yes? Okay. You are reducing aldehyde. When you are reducing, it's a very strong reagent, right? So what do you get, children? This is a reducing agent. And we know that when there is a reducing agent and you reduce aldehyde, you get 1 degree alcohol. Yes. So if this is acetaldehyde, you're going to get ethanol. This is ethanol. Now, coming to H2SO4, children, this is a dehydrating agent. What does it do? It removes water. It removes water, right? So dehydrating agent doesn't always mean it removes water. So here, talking about this, if we know you're having alcohol, how do you predict that it's a dehydrating agent? So alcohol gets converted into alkene. Yes, alcohol gets converted into alkene. So can I say that ethanol gets dehydrated to form CH2 double bond CH2. Did we see that here water was removed? Yes. So water was removed. That is how you think of dehydrating agent, that alcohol gets converted into alkene. Yes? Okay. Now you see, children, we got alkene here. What did we get? B was alkene. If you add HBr, can I say this is Markov-Nikov addition? Yes? Markov-Nikov addition means here, because you have both sides same, so you can add anywhere, right? So this is going to be CH3 CH2Br. To one you are going to add hydrogen, to other part you are going to get bromine. Markov-Nikov addition. So this was yes, children. Okay. Now this is an alkyl halide. This is what, children? Alkyl halide. This, children, is your aryl halide. When you add one alkyl and aryl halide, what reaction is that? That is Wurtz-Fittig reaction. Okay. In the presence of sodium and dry ether, you're going to get Wurtz-Fittig reaction. And what is that Wurtz-Fittig reaction, children? Your final product is going to be this one. Yes, this is going to be methyl benzene, or we call it as toluene. Just a minute. No. Just a minute. This is going to be this. Ethyl benzene. Because we have two carbons here, right, children? Okay, so do not get confused. We get ethyl benzene as our main product. Yes? Okay, is it clear to everyone? Let us move on to the next question. So next question on your screen, and try, everyone. Okay, children. I hope you all would have solved it. Okay. So let us see what's given here. Which of the following reaction is not an example of nucleophilic addition elimination reaction? Okay. So it should be nucleophilic addition reaction. Do not get confused. Okay. So it should be a nucleophilic addition. Along with that, it should be involving elimination as well. Yeah. So this both must be present. As we can see, children, in the first reaction, if you see, I'll break it down for you. I can write it this way, and NH2 I can write it this way. And as you know, this reaction is going to involve the elimination of water. So what am I going to get? CH3, CH, double bond, NH. Yes? Sorry. Yeah. So you're going to get this as your product. Yes or no, children? So did you see that there was an elimination, and this is also a nucleophile? Yes? And it's going to add. So this one is nucleophilic addition elimination reaction. This is correct. Yeah? Okay, good. Now as you can see here, children, here I have okay. This can be written as OSO2H minus, right? So when I take this here, so your Na is going to be here and this part is going to attach here. Yes? So what are you going to get, children? You are going to get and from here there can be a proton transfer. And your product is going to be yes, children? Okay. So this is how you got your product. Did you eliminate anything here, children? No, there was no elimination. So there was no elimination. So can I say this is our most probable answer? Yes, as of now it is correct. Similarly, you can do this both also. If I show you, you can write it like this. If you remove it this way, you're going to get your product. Yes. Similarly, you can do for this also. Yes. Okay. So we see that all these three, they're involving nucleophilic addition and elimination as well. Yes. So I can say that my answer is option B. So this is the correct answer because it involves only nucleophilic addition. Yes, children. Is it clear? Okay. So next question on your screen. Try everyone. Okay, children. So let us see what's given here. Okay. It's given here that the boiling point of aldehydes and ketones are higher than that of hydrocarbons, right? So aldehydes and ketones, they are high more than hydrocarbons. Is it correct? Yes, the statement is correct. Also, the reason is given. They have dipole-dipole interaction. Yes, because of this C double bond O group, there is dipole-dipole interaction. Yes or no, children? Yes. This statement is definitely correct. Looking at the next statement, the boiling point of aldehydes and ketones are lower than that of alcohols of molecular masses due to absence of hydrogen bonding. The next statement is telling us that your alcohols have higher than aldehydes and ketone. Yes or no, children? Because this one has intermolecular hydrogen bonding. But there is absence of intermolecular hydrogen bonding here, right? So this statement is also correct. So can I say that both statement 1 and 2 are correct? Yes or no, children? So both statement 1 and 2 are correct. Yes? Okay. So again, next question on your screen. Try everyone. Okay, let me discuss this question with you. Can I say that RMGX is nothing but your Grignard reagent? You're having carbon dioxide. So let me write down the structure of carbon dioxide here. Now, we know that this bond is both polar and covalent and ionic, right? So this is minus, this is delta plus. Similarly, oxygen is more negative, so this is how things work. So this is negative part and this is going to be your positive part. So your R is going to go to the carbon, MgX is going to go to oxygen. Right, children? Yes. So what are we going to get here? Near carbon, you have double bond O. So here your R comes and you have this double bond O. Yeah, but it has changed to O minus. This is just this, and OMGX you're going to get here. Yes, children? Yes. Yes or no? Yes. Now what we do, if we add water, okay? If we add water, this is how the bond is going to break, and you're going to get H here, you're going to get OH here. So what are you going to get, children? RCOOH plus MgOH. Okay, this is the mechanism of the reaction. So what is Y, children? Y is something that we got here. This is Y. And what is Y? Y is nothing but R, C, double bond O, O, Mg, X. Right? So where is it given? So this is RCOO minus and MgX, where it is written. Is this R3? No. Is this RCOO minus? No. Is this RCO whole twice? No. This is only this option is correct, which is RCOO minus and Mg. Right? So your answer is going to be option A. Is there any doubt till this much? I hope not. Okay. Now again, next question on your screen. As you can see, this is your sodium salt, okay, of acid, and you are converting it into CH3CH3. Which reagent is that which reduces the number of carbon from the parent atom and gives you this? This is nothing but your calcium oxide. This is a direct question from NCERT. Okay. So now try this one, children. Now children, let us see. It's a very important question, and also this is your question from directly from NCERT in text. Okay, you have this question in your NCERT in text. Okay. So now looking at this, we are having two groups here. And what are those groups who can identify? We are having this part is your ester. Yes. What is the formula of ester? R COO R dash. If this is your R, this is COO, and this whole entire part is your R dash. Whole entire part is your R dash, right? So we are having ester group here. Is it clear? So this part is your ester group. This part is your ketone. So we are having two groups here. Yes. So the first part was to identify the groups, main groups. Now NaBH4. This is reducing agent. Okay. This reducing agents, they are having some specificity. Yeah. And what is its specificity? This reagent will not reduce. It's not going to reduce your ester. It is just going to reduce ketone. It's just going to reduce ketone. And when it reduces ketone, it is going to form alcohol, which will be of 2 degree. But this part will be as it is. So now can you tell me what is going to be the product, children? So this is your main. Then when you reduce it, this part is going to get reduced. That means that is going to get converted into OH. Yes. So here you got 2 degree alcohol. You got 2 degree alcohol. Yes or no, children? Yes. So can I say this is our major product? And this part not reduced. Yes. So did you all understand, children? It was it's an important question. Reagents, you get questions from the important reagents, and this was one of the important reagents. So that's it for today, children. Okay. So I'll see you in the next class, children. I'm a bit of unwell today. So we'll see you in the next class, children. Thank you and bye-bye.